Now to make the things more clear, we will go to the general and property tab, and then we will select some structural steel members. So to do that, we need to go to this property and left click on section database. So in section database, we can see that there are various structural steel section libraries that are already inbuilt in the software. So we can select, for example, let us say British sections, and we can go to UB. So we can select UB 457 into 152 into 52. 457 is the height of the member, 152 is the width of the flange, and 52 is the kg per meter unit weight. So it means that the weight of the section is 52 kg per meter. And left click on add, and similarly we can select other sections also. So let us say if we want to select the channel also. So channel, we can consider it as channel of, let us say 125 into 65 into 15. 125 is the height of the member, 65 is the width of the flange, and 15 kg per meter is the unit weight. And similarly we can select a small structural UB size also. The UB means uniform beam. So we can select UB 305 into 165 into 40 also. So we go to this member and we can select it as UB 305 into 165 into 40. After that, we can select this member also as 305 into 165 into 40. Make sure that you don't select column while making a rectangle like this. And we can select these small tertiary members as channel of 125 into 65 into 15. And this member can be selected as this main portal frame member, or main moment connection member. And after that, we can select the column size also as same this member also. So now we have assigned properties to all the structural steel members. And after that, I will like to make some things more clear to you. Basically what happens is that when we select this member here and this member here and go to 3D view, so here you can see that this member is coming inside this member. So although this member shall get terminated here only at the face of the flange, but it is coming to the center, which is not correct. So it may result in underestimation of the bending moments, because the whole force will get transferred here, whereas there shall be some eccentricity to the actual force or the moments that are happening here, because we assign connection to the face of the member. So here you can see that we need to finish this member on the face of this column only. So although this is a practice that is really done by the structural engineers, but I will suggest you to do that. So how to do that is the main thing. So we go to general specification, we left click on beam. Here is this command called offset. So offset is the command that will help us in correcting that thing that we have discussed earlier. So we go to location and start. Here we can select as offset of global X. This is the global X axis. So we want to offset this joint of this member by 0.225, because we have selected UB 457. As I told you earlier also, that 457 is the height of the structural steel member. So we need to select it as 0.225 and left click on add. Similarly, we need to offset this member also, but before doing that, I would like to assign this specification here. Left click here and then left click on assign. So if we want to check the 3D view here, we need to select start here. So I'm repeating this. I had done the mistake earlier that we need to select the location as start, not as the end. So when we when we will do this, and then left click this member here and this member here, then here we can see that now the connection is correct. That is, we are terminating the structural steel member here at the column face only. Similarly, we need to select beam and offset as location end and x as 0.225. So we need to do the same thing here also. We need to select offset x as minus 0.225 because we need to go along this minus x. So here you can see that the stat has drawn some hidden lines here. So it means that now the member is offset by 0.225 mm distance. Similarly, we select Shift and E option on your keyboard to switch on the local incidences. And similarly, we select this starting point here and ending point here. So now we have studied what exactly is the importance of this offset command. So if we want to fine tune our bending moment and shear force results, then we need to do this offset commands specifications. And similarly, one more thing that I like to add here, you can press Shift plus E on your keyboard again to switch off. If we want to model a floor on this structural steel member, for example, if we want to model a 150 mm slab here, so we can left click on add 4 knotted plate and select all these 4 members here. So now we have modeled a plate here. To select the plate, we need to select plates cursor here. So you have selected this plate here, and we need to go to general and property, and we need to select the thickness here. And on the top it is plate element thickness. You can select it as 0.15, and we can select the material as concrete. Left click on add and close. So selecting this plate cursor here again, and we can left click on assign to selected plates and gauge. And when we will go to the 3D view, here you can see that again something is wrong. Again something is not as desirable as what we want, because this 150 mm RCC slab should be over the structural steel member, not on the center line of this whole structural steel member. So to correct this, what we can do is that we need to select all these members here, select the beams cursor here and select all these members here. We need to go to general and specification, and we need to go to beam, offset, and XY as minus 0.225, because overall the maximum height of this member was minus 0.457, and the height of the plate that is being modeled is on the center line. So that is why 457 divided by 2 approximately minus 0.225. So and y is plus y is on the upper side, and we need to down these elements. So we need to left click on add, and we need to left click on assign to selected beams and yes. So similarly, we need to go to beam and offset and end and y minus 0.225 and left click on add. So although what we have done here is a rough method, and one more thing that I'd like to add here, now this offset command that we have assigned earlier to these members are now superseded. So what we need to do is that we also need to offset these members along the minus y direction as well as along plus x and minus x direction. So we can change it to minus 0.225 and this member also. So now if we see this whole structure in the 3D view, so now you can see that this is now a correct approach. Although we have done like one mistake here, that we don't need to offset the channels also by same dimension, because channels are of 200 mm size only, and this beam also is of somewhat less size. So what we can do to rationalize this whole 3D view is that we can offset this channel by 100 mm only, that is MC 125, and this whole structural sheet arrangement is now perfect. That is, this member is now resting on this as we desire, and the structural structural RCC slab is on the top. And if we will see the channels here, we can see that now the channels are hanging in the middle. So here you can see that channel is not below the deck slab. So what we can do is that we can go to specification again, and we can assign a new specification, that is y minus 0.1. And similarly for the end point also, and to reduce our working time, we can go to CH125 into 65 into 15 and select these whole members here, and go to specification, select this, and we can go to left click on assign to edit list, press Ctrl plus V on your keyboard, and left click on assign. Similarly for ending point also. So now if we check the 3D view, here we can see that still it is not correct, as the structural sheet member is going inside the deck slab. So what we can do is that we need to change it to minus 0.2. Basically, this problem is occurring because we are offsetting the whole member, both of the members. So we need to take the differential of this, but to make the things precisely or correct, then what we can do is that we can change this to minus 0.15 to check that whether the things are now correct or not. Now we can see that the whole arrangement is now somewhat correct. That is, now the member is now resting here, because as I told you earlier also, because we are offsetting both of the members, so we need to take the differential, not the height divided by 2 for the small tertiary members. So sometimes you do need to do permutation and combination to check that what is suitable for you and what is not. There's one more thing that I'd like to add here, because in structural sheet members we also have bracings here. So how we can add the brace is that we can just left click on add beam, and left click here, and then left click here again. So similarly we need to model bracing from this point to this point. So how we can make sure that this member will only take compression, or it can only take tension, or it can only behave in a particular manner. So how we do that is that we can go to left click on beam, and we can select compression, tension, or we can assign releases, and we can assign truss also. So different structural engineers have different perspective of how to deal with the bracings. I will not suggest you to assign truss members to the bracing, because in reality, some bending moment may come in the bracing structural steel members. So how we can avoid that is that we need to assign releases to these bracings. So to assign releases to the bracing, what we can do is that we can select both of these structural steel members and we can left click on start M by MZ and end M by MZ. So this also was just a basic introduction to how we assign properties to the structural steel bracing. But what we need to do is that what I am trying to convey here is that the bracing connection also need to be justified. That is, we also need to make sure that this bracing is being converging on this column on this working point only. Because otherwise, for example, if we are seeing here, the bracing is not coming on the center line of this beam, it is coming on the top of this member. So it may result in the underestimation of the axial force and bending moments. So as I told you earlier also, that we need to bridge the gap between this physical models and analytical models. So what we need to do is that we need to make sure that in fabrication drawings or on the site, this structural steel member shall be center line of the structural steel member shall be on the center line of this column only. So if we are talking about our structure, so in the bottom we can see that the center line of these both members are coinciding on this particular joint. So we can say that this detail is being correctly followed here. But I need to ask you this question, that how we can model this type of bracing connection. Let us say the fabricator is saying that he cannot due to length of the bracing, he cannot do this type of connection on the bracing column intersection, or he's saying that he wants to follow this type of connection. Then how we can analyze that type of structure? What we need to do is that we need to introduce a joint here. We need to introduce a small joint. So let us say the fabricator is saying that he need to offset the bracing column connection by minus 0. Let us say minus 0.4 meter. Sorry, plus 0.4 meter. So we can need to select Y plus 0.4. You need to press Shift plus K option on a keyboard. And let us say the fabricator is saying that he can draw bracings like this, or he can make bracing connection like this only. So with this we can make sure that this particular connection is being followed here. Because let us say as I told you earlier also, that let us say we are offsetting the connection by 0.4 meter. So this is the thing that I am trying to convey here, that I am repeating this thing again and again, that we need to make our structure as much as possible to the physical structure or the actual structure that will be constructed on the site. So now we have started this releases command and offset commands. So now we can understand that how we can define a particular flow, how we can assign releases, and how we can assign releases to the bracings also. And the most important thing, how we can assign offsets also to make our structure as much as possible to the actual steel structure.